So here we've got some word problems with our 45, 45, 90 questions. Let's get right into it. And this one, first one is very close for me, being a baseball coach. Math often shows up in sports in ways that we don't realize. Take, for example, the baseball diamond. It is actually, so this is what a baseball diamond is. It's actually a square, okay, with bases set at 90-degree angles. Okay, and that's actually going to be home plate, but we'll draw a little 90-degree angle there. I know it's not perfect. Bear with me, okay? The bases are 90 feet apart. So each one of these bases is 90 feet away from the previous base, okay? So all of these sides of this square are 90 feet. Question is, how far apart from home plate is second base? So how far is it to get from home plate to second base? This is what we're looking for. So we've got a square. We're cutting it diagonally across. So these angles are going to be congruent because their sides across from them are 90 degrees. So we've got our 45, 45, 90 triangle. Okay. In this 45, 45, 90 triangle, we are looking for our hypotenuse, but we are given the leg. So if we're given the leg, all we got to do is multiply by root 2. So we take our leg, 90, multiply it by root 2. That is a perfectly acceptable answer, okay, from the standpoint of it looks clean, okay? However, I'm not going to tell somebody that I just threw the ball 90 square root 2 feet. So I am going to evaluate this. 90 square root 2 is going to be 127.279 feet. And that's how far it is when you're throwing it from home plate to second base. This is something that I've done in the past to help replicate this to practice for players. We try and figure out how far we need to throw. So we set somebody 127 feet away from somebody. We'll actually do it in yards on a football field sometimes. So we'll divide that by 3, and we know that we've got to set that base a little bit over 42 yards away, okay, to be able to practice that throw. So, next one. A square has a diagonal with a length of 10 centimeters. So, we've got a square. Its diagonal is 10 centimeters. We're trying to find the length of each side. So, if it's a square, we know that these angles are going to be 45 because they're going to be congruent across. We're a square, remember, so all of these sides are congruent to each other and the diagonals bisect opposite angles. So because of that, we have the hypotenuse, and because that hypotenuse is a whole number, I'm going to multiply by root 2 over 2. So I'm going to take my 10, I'm going to multiply by root 2 over 2. 10 divided by 2 is 5, so I've got 5 root 2 left over. And that would be a perfectly acceptable answer, but again, trying to find the length in centimeters, that's not necessarily a way that makes sense to us, so let's evaluate that in our calculator. 5 square root 2 is the same as 7.071 centimeters. Both of those would be acceptable, but the rounded number gives us a little bit more context and makes a little bit more sense the way we measure things. The roof of a house has a slope of an isosceles right triangle. The slope of the roof is 24 feet. So what is the height of the roof? We've got these two triangles here, okay? We have right angle right here as well, okay? We've actually got a couple 45, 45, 90 triangles because those are also 45. So I'm trying to find the height, which means in this 45, 45, 90 triangle, they gave me the hypotenuse. It's a whole number, so I'm going to use the multiply by root 2 over 2. So I take my 24, multiply by root 2 over 2. That's going to cancel out. 12 root 2 feet would be acceptable. but I can also evaluate it in my calculator to get 16.97. That 5 is going to round up to a 1 feet. And then our last example here, grain elevators are conveyor belts used throughout the Midwest to take produce, like wheat, to the top of a silo for storage. How long would the belt of a grain elevator need to be if the bottom is 50 feet from the base of a silo that is 50 feet high? What in the world is going on? Let's draw a picture. So for those of you who don't know, a silo is essentially a cylinder, okay, with a little cone on top sometimes, that's going to hold, like in this case, grain, okay? This one is 50 feet tall, okay? So this side is going to be 50 feet. This grain belt, they're saying, okay, is 50 feet from the bottom of the base. So we've got a 50-foot side going up and down. We've got 50 feet going left and right. And this is where our belt is, okay, that's going to take that grain to the very, very top. Because this is 50 and this is 50, we're going 50 feet up, 50 feet out. We know that these are also going to be 45-degree angles because if they're isosceles triangles, okay, and it's a right triangle, then our other angles have to be 45 degrees. So how do I solve this? I'm given the legs, so I'm going to multiply by root 2. So 50 root 2, that would be a totally acceptable answer if we knew what 50 root 2 meant. But if I'm trying to measure this fully, 50 root 2, 50 times root 2 is going to be 70.71 feet. Okay, and that's how we're going to get our way up. So 70.711 feet, that's how long our belt needs to be. And those are some word problems. The big thing, draw a picture if you're not really 100% sure. Use our formulas. If we know that we have the leg, multiply by root 2. If we have the hypotenuse, we're either going to divide by root 2 or multiply by root 2 over 2. And then we're just going to simplify where we can.